Hello, welcome to this section of Calculus Extra Practice with Integration. In the last section, we introduced a incredibly important topic in calculus called using integrals to calculate the volume of an object using the shell method. So here we're going to work some more shell problems, mostly just to give you some comfort and some experience and some practice with doing it. But up until now, you really have all the tools you need to tackle any shell problem, because once you know how that function, the form of the integral arises, you can apply it to any problem you have, and at that point you're just drawing on all of the skills that we've already learned and how to integrate things in order to get the job done. So let's get some practice with that right now. What if you had a function, and on a test it could be something as simple as, here's your function, f of x is 4 over x cubed, and we're looking in the region of 1 to 3, and you need to revolve this function about the y-axis. The interval along x that you have is from 1 to 3, and you want to find the volume of this revolution, basically. And you're revolving it about the y-axis. So when you revolve around the y-axis, it's a huge clue that you're going to be using the shell method. You're going to integrate from 1 to 3. That's the region that you care about of your function. And what you're integrating is 2 pi x times f of x dx. And so when you do this integration from 1 to 3, it'll be 2 pi x. F of x is just given as 4 over x cubed dx. Now this is a nice setup here because this x actually cancels and makes this x squared on the bottom. So this integral really will be from 1 to 3, and we'll pull the 2 pi out. And what it'll basically be, well, you know what I want to do is I want to pull 2 times 4 is 8. So really I'm going to pull out 8 pi from 1 to 3. And the only thing you have left on the inside here is x to the negative 2. Make sure you understand that. Basically, we take the pi out, we take the 2 times 4 out, making that 8. All we have left is 1 over x squared. But I like writing that as negative exponents because ultimately I need to integrate that, and so I need to use the exponent. So what you're going to have is 8 times pi times this integral, which is going to be 1 over negative 1, x to the negative 1. Because negative 2 plus 1, take the exponent plus 1, you get negative 1. So we get negative 1 in both places, and we're evaluating this from 1 to 3. All right, and so tidying this up just a little bit, what you're going to have is this negative is going to give you negative 8 pi over x evaluated from 1 to 3. Negative 8 pi over x because the x is to the negative 1 power, so you can make it go downstairs again. And so this is what you have. So we evaluate this at the top limit of integration. So what we'll have is negative 8 pi over 3, evaluating at the top limit, minus evaluating at the bottom limit, 8 pi over 1, like this. So all we need to do is tidy this guy up, find a common denominator somehow, and then we're good to go. So let's go ahead and just tidy up what we have. We have negative 8 pi over 3, and this is going to be a plus. Over here we're going to have 8 pi. Let's just go ahead and keep it over 1 to make it easy. So this plus is all that really happens there. Now we want to find a common denominator. So if we want to get a common denominator here, the easiest thing to do would be to multiply top and bottom of the second fraction times 3. Okay? And so then what we're going to get is, here's negative 8 pi over 3 plus 8 times 3 is 24, so you have 24 pi over 3.